Today, Jim's breaking down how lightning actually forms.
Right, so yeah, I mean, this was yesterday's storm. It started right around 4 o'clock. And note the lightning tracker up here in the corner. There were times yesterday we were seeing 400 to 500 lightning strikes every 15 minutes.
Wow.
You heard it. It was constant out there. Those heavy storms rumbling across southwest Florida. And yeah, this is sort of a common occurrence this time of year across southwest Florida, unfortunately. Let's go ahead and take this full, guys. I'll take it over to the wall from here because I want to take a look at sort of the setup. So the first thing you need to know is how atoms work, sort of the ingredients to an atom. You have your neutrons and your protons. Those are all in the nucleus. Those stay put. But around that nucleus, you have your electrons. They can get stripped away from the atom when there's collisions of molecules. And that's exactly what goes on in thunderstorms, and it's the big part of the reason why we do see lightning from those storms. So here's what happens. We've talked about this before. The way you get clouds and showers, thunderstorms to develop, you get warm air at the surface rising. As it continues to rise, those big, tall cumulonimbus clouds, those thunderstorm clouds start to form. And within that, you have very turbulent motion. You have upward and downward motion, and you have water droplets. You have ice particles within that are moving all over the place and colliding. As those molecules collide, you're going to strip electrons, and you're going to start to form some charges here, some positive molecules, some negative molecules. They set up in the cloud, and because of the forces between them, you're going to get charge separation to set up. Typically speaking, you're going to get your positive charges to the top of the cloud, negative charges to the bottom of the cloud. And because we have this disparity in the charges, it's going to try to get rid of that. And the way it does that is by your lightning strikes. You're going to have strikes going on within the cloud. In a few cases, you're going to have strikes going on from the cloud down to the ground. Now, I want to make note here, too. This is what we typically see with lightning strikes, the bottom of the cloud striking the ground. But in a few cases, you get what's called a positive stroke. Those positive charges in the storm's anvil strike down to the ground, too. They tend to be the strongest of the lightning strikes. We see the most energy with that, and because they're in the anvil, those sort of thin clouds that go well out ahead of the storm, sometimes it's not even raining when you get those lightning strikes. That's why we always tell you, if you're close enough to hear thunder, you're close enough to be struck by lightning. It's something we really have to keep in mind this time of year across southwest Florida.